Hi, in today's lesson, we're going to talk about terminating and repeating decimals. So this very first section has several fractions and we're asked to write them as a decimal. And then it says to use that bar notation if needed. And bar notation is used when we have a repeating decimal. So I'm going to look over here at number 1, and we're going to do these without a calculator. So if I want to change the fraction 16/20ths to its equivalent decimal form, there are actually several ways that we could go about doing this. One way is we could try and change our fraction so that it has a denominator of 100. And we could actually easily do that with this one because 20 is a factor of 100. Another way that we can do that, and the way that I'm going to show you, is to use division. Fractions are really just an expression of division. This literally means 16 divided by 20. That fraction bar is a division bar. So it means 16 divided by 20. So I can go ahead and write that just like this. So that 16 divided by 20 is what I have written there. The 16 is in the box or the house, however you've referred to it before. So we think 20, how many times does 20 go into 16? Well, it doesn't because 20 times 1 is 20. So it goes in 0 times. We can rewrite 16 as 16.0. That has not changed the value of 16. We're going to bring that decimal point up. And then we're going to ask ourselves, how many times would 20 go into 160? So I'm ignoring the decimal point right here. So 20 times 5 is 100, right? 20 times 6 would be 120, times 7 is 140, times 8 is 160. So it would go 8 times. 8 times 20 we just said is 160. Remember, once I've brought that decimal point up, I'm going to ignore it. And then I subtract, and I'm left with 0. So I'm going to end my decimal there. So 16/20ths is equivalent to the decimal of 8/10. Okay, so that's how we're going to work these. I don't need to use any bar notation because this is not a repeating decimal. If I had gotten something like 0.88888 and so on, then I would have to use the bar notation, which we'll talk about later. All right, let's look at the next problem, number 2. This time I have 30 over 120, or 30 divided by 120. Now, for this one, I'm actually going to do it slightly differently. It does mean 30 divided by 120. That is what it means. But it's not as easy for me to do the factors, or the multiples of 120 in my head. So I'm actually going to simplify this fraction a little bit before I do that division. For example, I know that I can divide both my numerator and denominator by 10. So that leaves me with 3/12. Oh, and I know that 3 and 12 are both divisible by 3. So that leaves me with 1/4. Now, some of you automatically know the decimal equivalent for 1/4. We know that that is 0.25 or 25/100ths. But if you didn't, we could still use division, that we can do 1 divided by 4. 4 does not go into 1, or we could say it goes into 1 0 times. Bring my decimal up and change that to 1.0. 4 goes into 10 twice. 2 times 4 is 8. So now I'm doing 10 minus 8, which is 2. 1.0 and 1.00 are the same. I've not changed the value. So I'm going to bring that 0 down. 4 goes into 25 times. 5 times 4 is 20 with none left over. So yes, we see, even when we divide, that's where we got the 0.25. But as I was saying, a lot of people already have this fraction decimal equivalent memorized. Okay, let's look at number 3. Now this time we have a mixed number, 1 7/8. So for this one, you can't just jump to the division. So 7/8 does mean 7 divided by 8. I would recommend, just to keep things simple, let's start off by rewriting this as an improper fraction. So to do that, remember you take your denominator, in this case 8, multiply by the whole number. So I'm going to do 8 times 1. You start this way. And then I add the 7. So 8 times 1 is 8. 8 plus 7 is 15. And you keep your denominator. So 1 7/8 is equivalent to the fraction or improper fraction 15/8. So then I'm going to divide. So that means 15 divided by 8. So 8 will go into 15 one time. Okay, 1 times 8 is 8, and you have 7 left over. So you want to keep going till you get a remainder of 0 or until you get some sort of repeating pattern here. So 15 is equivalent to 15.0. So we'll bring our decimal point up and we can bring that 0 down. So 8 will go into 70 how many times? 8 times. 8 times 8 is 64. And then we do 70 minus 64, which is 6. I don't have a remainder of 0, so I'm going to rewrite it as 15.00 and bring that down. And this is, when you're doing this, remember you should be writing neatly, so that way everything lines up and you don't get confused. Okay, so now I'm going to ask myself, how many times would 8 go into 60? Well, 8 times 7 is 56, so 7 times. We said 7 times 8 was 56. 60 minus 56 is 4. I'm going to have to add another 0 and bring it down. 8 will go into 40 5 times. 5 times 8 is 40 with none left over. So 1 7/8 is equivalent to the decimal 1.875. Okay. So now I'm going to give you a chance to try a few on your own. So I want you to do 4 through 9. And I will give you a tip. Number 9 might be a little tricky. Okay, so pause the video and do 4 through 9 now. Okay guys, so here are the answers and the corresponding work. I don't believe I said it before, but you should have shown your work for each of these problems. You can certainly use a calculator to check over your answers, but you really need to have your work shown in order to receive credit. So what you may notice is that in numbers 4, 7, and 9, we ended up with repeating decimals. You should have noticed the pattern where it repeats. In number 4 in particular, only the 6 repeats. So you'll see how I put that bar on top of just the 6. In number 7, only the 3 repeats. So the bar only goes over the top of the portion that repeats. In this case, only the 3. If you wrote the bar over the 1 and the 8 and the 3 all together, then you're saying the decimal is 0.183, 183, 183, 183, which is not what is the case. Only the 3 is the repeating portion. And then, of course, number 9, most people usually locate that bar correctly. Only the 5 is repeating. That is the only digit anyway. Okay, so we're going to go ahead now and we're going to look at the next section. This time we have decimals and we're just going to write them as fractions and we want them to be in simplest form. So if you've got a decimal and you want to change it to a fraction in simplest form, the first thing that I suggest is you properly say the decimal. What I mean by that is, all too often we read this as 0.26. That's a quick way to say it, but it's the correct name for this decimal is 26 hundredths. So if you think about how I just said 26 hundredths, you easily know what the fraction is. So 26 hundredths means 26 over 100. So that is the equivalent fraction, but now we just need to simplify. So I know just from first glance, 26 and 100 are both even, therefore I can divide both of these numbers by 2. So I end up with 13 50ths. 13 is a prime number. It is not a factor of 50, so this is 13 50ths in simplest form. That's it. Let's go to number 11. So again, we're going to read the decimal in the correct form, or the correct terminology, not 0.75. This is 75 hundredths. So 75 hundredths means 75 over 100. And now we can simplify. Well, they're both divisible by 5 because any number that ends in 5 or 0 is divisible by 5. But I also know that 75 and 100 are also divisible by 25 if you think about in terms of money. So if you had 75 cents, that's 3 quarters. So 75 divided by 25 is 3. And 100 divided by 25 is 4. And some of you may have known that 75 hundredths was equivalent to 3/4 just from prior experiences. So that's going to be equivalent to 3/4. Okay, and looking at number 12. So this is 4/10. 4/10. So 4/10, 4 over 10. And then again, this one can be simplified. 4 and 10 are both even, so I can divide them both by 2. So that becomes 2/5. Okay, so now you're going to practice some of these on your own. So I want you to do 13 through 18. Make sure that you're showing your work. So go ahead and pause the video and do those problems now. Okay, everybody, so now you're going to check over your answers. So you might need to pause the video to make sure they're correct. The problems where you ended up with mixed fractions or mixed numbers, like number 14. So that was read as 4 and 48 hundredths. So when I started off by writing it down, I wrote the whole number 4 and then the fraction 48 hundredths, and then just simplify from there. Same thing for number 17. I wrote it as 11 and 15 hundredths, so it looks like that, and then just simplify the fraction part. Okay, so once you've completed this, you'll do the independent practice. The independent practice talks more about repeating decimals and the patterns that you see there, so you may need to take a peek at the answer key when you get ready to do that. If you have questions about any of the work from today, please do not hesitate to see me for help.